you have a very important file on your computer, but you've forgotten your Windows login password. What would you do? Most of us would first think of resetting it via email. Of course, there are other methods too, but if your email address isn't linked to the computer, there's only one way left to recover your file. Trying every possible combination one by one. I know, it's a crazy idea, and it's not logical at all. Because with a regular computer, trying all those combinations could take thousands of years. But if you had a quantum computer, it could act as if it could see the future. In other words, it could behave as if it was bringing information from the future to the past. And thanks to this, it could find your password in seconds without trying any combinations. But how could a computer possibly get information from the future? It sounds like science fiction. Do these devices not do any calculations at all? Do they have a magic wand or something? Of course, it's not exactly like that. Quantum computers do perform calculations too. But unlike a classical computer, it doesn't try each possibility one by one. It evaluates all possibilities at the same time, and wrong answers are basically ignored. The correct answers stand out. It's as if the quantum system has chosen them from the very beginning. What do you mean? Do these computers know the answer in advance? Isn't this really confusing to you too? This is such a strange situation that it makes you rethink your relationship with time. But there are experiments and findings on this topic that I honestly had a hard time believing when I was researching them. I'm sure you'll feel the same way in a moment. But before we get to those experiments, let me tell you about two fundamental features that distinguish quantum computers from classical computers. The basic unit of classical computers is the bit. For quantum computers, it's the qubit. In classical computers, each bit can only take on one of two values. It can be either 0 or 1. So the system's language is very clear. On or off, black or white. That's why a classical computer has to check every possibility one by one to try a password. But things change with quantum computers. Qubits can be both 0 and 1 at the same time. It's like a coin that's been tossed in the air and hasn't landed yet. So, whether it's heads or tails is still uncertain. That state of uncertainty gives it the ability to think simultaneously. This ability is called superposition. I talked about this in detail in the quantum mind theory video I prepared a few weeks ago. Those who haven't watched it can check out that video as well. Thanks to this feature, quantum computers can keep millions of combinations in mind at the same time. Now, to make it clearer in your mind, let me give you a more concrete example from everyday life. Let's say you walk into a dark room. A classical computer would look at this room with a single flashlight each time. But a quantum computer lights up the entire room all at once. It sees all the possibilities at the same time. Now, we mentioned two main differences. This is the first one. The second is quantum entanglement. Two qubits become so connected that even if they're light years apart, when one is affected, the other responds at the exact same moment. It's as if there's an invisible bond between two entangled quantum particles. In fact, Albert Einstein once called this a spooky action at a distance. It's thanks to these two features, superposition and entanglement, that quantum computers can process information much faster than classical computers. This difference in speed was clearly observed for the first time in 2019 with Google's quantum supremacy experiment. A quantum processor with 53 qubits completed a task in just 200 seconds that would have taken a classical computer 10,000 years. That's almost 3 minutes. But the strangeness of quantum computers isn't just about speed. Some things observed in experiments suggest that this might also have something to do with the direction of time. It's as if quantum computers not only see the future faster, but can also interfere with the past. In 2019, scientists conducted an experiment so remarkable that the relationship between quantum computers and time was questioned once again. A team from the Moscow Institute of Physics and Technology tried to reverse the time of a quantum system using IBM's quantum computer, and yes, they succeeded. In the experiment, an artificial atom, that is, a quantum qubit, was used. The goal was to return the qubit's quantum state to its previous condition. They managed to go back in time by about a millionth of a second, but only for a very short interval. In the experiment, a deliberate error was introduced into the quantum system. Then, by reversing time, they tried to restore the system to its previous state, and this was successful with 85% accuracy. Now, when I talk about rewinding time and all that, it feels like I'm describing a scene from a science fiction movie, but let me explain what this really means. The quantum system acts as if it has returned to a previous state during a computational process that should normally move forward. This is a very unusual situation in the history of physics. Because what did classical physics tell us? The arrow of time only moves in one direction. The past is in the past, it can't be reversed anymore. In other words, time always flows forward. But this experiment completely overturns that rule at the subatomic level. Yes, we're talking about a very short period of time. And yes, maybe this doesn't mean time travel in real life, but for the first time, scientists managed to return a quantum system to its previous state. The direction of time was reversed, even if only for a short moment. This makes us think about something. Maybe quantum computers can connect with both the past and the future at the same time while performing calculations. Now, the encryption example at the beginning of the video probably makes more sense to you, right? So, can a quantum particle travel to the future and interact with its past self from there? In other words, does time always flow forward like a straight line, or does it sometimes bend back on itself and form a loop? How have we always imagined time? Past, present, and future. But in the quantum world, these 3 points in time are all connected. In fact, sometimes they turn into a web of overlapping possibilities. And this leads us to the following conclusion. Maybe what we call time doesn't flow at all. It's just that we think it does. In other words, time might be an illusion. Now, I mentioned that there are some incredible experiments about these topics. Look, one of them was conducted in 2014. In an experiment at the University of Queensland in Australia, scientists managed to simulate the idea of a time loop in a laboratory setting. The physicists wondered about this. Could a particle possibly communicate between its future self and its past self? In other words, could certain information at the quantum level bend the direction of time? In the experiment, 2 quantum particles, that is, 2 photons, were used. These 2 particles were linked together through quantum entanglement. Then, during the experiment, the scientists decided how they would measure one of these photons. As a result, they observed something strange. The measurement they made seemed to determine how the other photons should have behaved in the past. But how could this be possible? Normally, nothing can affect the past, right? This goes against the principle of causality. In other words, normally the cause comes before the effect. But here, the situation is exactly the opposite. A choice made in the future seems to be shaping the past. It might be a bit hard to grasp, but let me explain it with a concrete example from everyday life. Let's say a friend of yours enters one of 2 doors to a tunnel, but they're moving so fast that you can't see which door they went through. So, you decide to install a camera in the tunnel. But here's the strange part. If you turn on the camera, your friend acts as if they went through only one door from the very beginning. But if the camera isn't on, it's as if they went through both doors at the same time. So, once you decide what measurement you're going to make, what it does seems to change based on that decision. It's as if a decision made in the future is affecting the past. In this experiment, they tested this idea through quantum entanglement established between 2 photons. In the subatomic world, observation affects the past. Yes, this was already known. Physicist John Wheeler put forward a theory in the 1970s that shook the scientific world. Whether a particle behaved like a wave or a particle in the past can be determined by an observation we make in the future. About 40 years later, Wheeler's proposed thought experiment was practically confirmed for the first time in 2007. An experiment conducted in a laboratory in France revealed the following. If a photon is observed, it behaves like a particle. If it is not observed, it behaves like a wave. However, in the 2014 experiment, it was found that it wasn't just observation that affected the past. It was determined that the future state of a particle interacted with its past state. So, not only observation, but also decision has an effect on the past. And this experiment didn't just make us question the direction of time. It also made the cause and effect relationship a subject of debate. So, what does all this mean? How does a quantum computer make use of this strangeness? How is it that it can find that password, which we've forgotten and is made up of millions of combinations, in just seconds? There's a technique used in some algorithms of quantum computers. Post-selection. Remember how we said that quantum computers evaluate all possibilities at the same time? Well, in this technique, the paths that don't lead to the correct answer are basically ignored by the system. Only the single path that leads to the correct answer remains. This makes the system act as if it already knows the answer in advance. What was superposition again? it's seeing all possibilities at once. In post-selection, it means choosing the most correct one among those possibilities and ignoring the others as if they never existed. Let me give you an example. Let's say there's a giant maze in front of you. What does a classical computer do? It tries every path one by one. Remember the password example. There, it was also trying all the combinations. Here, it moves forward without knowing which dead end it will hit. But a quantum computer tries all the paths at once. It picks only the path that leads to the exit, as if it was always there. It acts as if all the other paths never even existed. So, classical computers spend time to find the answer. In quantum computers, all the answers already exist. It just needs to pick the correct one. Now, another question comes to my mind. Could quantum computers actually change the way the human mind works in the future? Could they even affect our decision-making processes and our understanding of reality itself? As humans, we usually fear uncertainty. What do we do when we can't cope with it? We make hasty decisions. However, in some situations, letting options mature and being able to consider opposing ideas at the same time can help us make much healthier decisions. Just like the concept of superposition in the quantum world, quantum computers might teach us a new way of thinking in the future, providing us with mental flexibility. Maybe we'll all get to know new concepts called quantum mind or quantum intuition. So, will this quantum way of thinking only affect humans? As you know, these days we're not just talking about human intelligence. There's another kind of intelligence that's entering almost every area of our lives: artificial intelligence. The merging of quantum computers with artificial intelligence could take the evolution of intelligence to a whole new level. The artificial intelligence systems we use today are still dependent on classical computers. In other words, all decisions are ultimately made based on ones and zeros. But if quantum and artificial intelligence merge, these boundaries could disappear. We all benefit a lot from classical artificial intelligence today. Most of the time, it offers logical and creative solutions. But quantum artificial intelligence will work with probabilities. It will be able to evaluate millions of outcomes at the same time, and maybe it won't choose the most correct answer, but the most meaningful one. For example, artificial intelligence is already very successful today at diagnosing and analyzing data. But an AI model running on a quantum computer could do much more. For instance, a doctor could evaluate all of a patient's treatment options at the same time. Moreover, it wouldn't just find the most effective treatment method. It would also consider the option with the fewest side effects, the fastest results, and the most affordable cost. Even though quantum computers still have limited capacity today, they have started to be tested in fields like drug discovery. Some major pharmaceutical companies are trying to understand new molecules using quantum algorithms. For now, only small steps are being taken, but in the future, there could be revolutionary developments. Google is working to combine classical artificial intelligence models with quantum algorithms in its lab called Quantum AI. But as I said, we're still at the very beginning of this journey. In fact, some scientists think that these devices will never be practical, because the environmental conditions are extremely sensitive and prone to errors. But let me remind you, the idea of flying was also considered impossible for centuries. We might be at a similar threshold for quantum computers in our current era. Things that seem like a dream today could become the new normal tomorrow. Just like how we're now accomplishing things with artificial intelligence that we couldn't even imagine before. A new era has begun with artificial intelligence. In other words, the partnership between humans and AI is turning into augmented intelligence. When the era of quantum artificial intelligence arrives, this partnership might not just increase speed and efficiency, but actually transform the very nature of thought itself. Some people describe this transformation as extended consciousness. We are now learning to accept our own limitations and to think together with these machines. Just as we can see into the depths of space with a telescope, with quantum artificial intelligence, we can explore the depths of our own minds. Nowadays, black and white thinking just doesn't work anymore. Maybe the polarization we experience today also stems from this. It's like this in every area. Now, everyone believes that only their own opinion is right. We don't see different perspectives, we don't hear them, and we can't even tolerate them. But there are gray areas in life too. That's why we need to be open to every possibility. That doesn't mean being aimless, just to be clear. It means having the courage to move forward in uncertainty, just like a quantum particle. A mind that keeps every possibility open until it's measured, but can choose a direction when needed. Today, all of us are searching for certainty. Which is the right decision? Which information can I trust? Which path makes more sense? But life isn't that linear, my friends. Information has increased, but trust has decreased. There are more decisions, but clarity is gradually disappearing, just like the quantum world. Maybe now we need a new form of intelligence. Humanity has experienced major turning points before. Our mindset has been reshaped with every technological revolution. The invention of writing changed the way we remember things. The printing press increased the speed at which we could multiply information. The internet accelerated access to information. Artificial intelligence has started to transform the way we think. Now, an even bigger step is ahead of us. Quantum artificial intelligence. This could give us an entirely new kind of mental flexibility in the face of uncertainty.